Today we're going to talk about our project about precision irrigation in nursery. It's the update that we have every year. So we're going to talk a little bit more about the results of this year and what we can learn from it. So just a quick recap about irrigation in nursery. As we all know, irrigation is essential for plant quality. So if you don't have enough water, the plant won't grow well. And if you have way too much water, then you will have some kind of trouble in terms of growth for the roots. So that's why you have good growth media, so soil, that would help you control that. But the amount of water that you're going to put is, as you will all know, really essential to control. So irrigation results often in significant water loss. So you're going to have overwatering and leaching, water not reaching the pots, and evapotranspiration from the plants itself. So it's a really complex system, especially if you go in nursery, because you're going to have a lot of winds and different places on site that will be different one from another. So quite complicated to take care of. And one of the big other big thing in nurseries, you're going to have a lot of different species at the same time, and they don't have the same water needs. So that's why we came with some kind of strategies to try to improve precision irrigation in nursery. So we had three different objectives in the project. The first one was to optimize irrigation management using wireless tensometers. And that was the first year we worked really on that, and it was just to see if we can shorten the irrigation pattern and try to reduce the amount of water you're going to use to have the same growth. And we won't talk about that today because it was the previous years, but in the update that we put on the website every year, you can see the result for that. There's two other objectives, and those we will cover today. The first one is to establish the best clustering practices. So it's 3 years part for that objectives. And we're going to come back in a few seconds. And the other one is to compare different strategy for the automation of irrigation in a nursery setting, in a commercial nursery setting. I will talk about that later in the talk. So let's start with the clustering. So like I said, we have a lot of different species in a nursery. You're going to have perennials, you're going to have shrubs, you're also going to have trees. And often growers will put them based on what they think about the growth and the size of the plants, and not necessarily based on what they need in terms of water. So what we want to give to the growers is what cluster would be the best in terms of watering. So it would be easier to water them all at the same time, because they're going to have similar needs. So the objective was to identify the best clustering practices for 25 species of shrubs and perennials. And if you saw my previous talks in the previous cluster, we did already start that part with 50 different shrubs and perennials. So it's going to add to what we already had. So you're going to have a clear picture of for every shrubs and perennial, or at least the most popular one. So we are expanding the amount of species we're going to have in our guide. And the treatment, so all of those species were put with reference species. So those reference species are really common perennials or shrubs, and we know them well because we did characterize their water need with tensometers. So we know exactly when to water them to have the optimal growth. So we wanted to see if they're going to cluster well together. So is it better to put, for example, that flower here with a nosta, or is it better to put it with a salix, for example? So that's what we're going to see today with a few examples. But let's start with the experimental setup. So for that experiments, we are working at Laval University Nursery. So we have a tunnel there, so we can control completely the amount of water you're going to put in the plant. So this is part of the setup. So we had, here you can see here with a solar panel, we had wireless tensometers. So those were measuring live the amount of water you have in the soil. And once you reach a threshold, you can start the irrigation. So it was automatic irrigation, all controlled with the software and the tensiometer in itself. So it's really efficient. And we had here all the valves, the automatic valves that were connected to the tensiometer hub. So the hub can control, there's 8 different places to connect either tensiometer or automatic valve to that hub. So it's really efficient. You can put it at different far from the electricity. It can be in the middle of the field and it's going to work. So we had all those automatic valves. We had 2-gallon pots. We used the same size for all the plants, so it would be more standard. And we use media that is often used in nursery. It's a bark-based soil mix, and it's from Fafard. It's the AgroMix N7, sorry. And we had also water meters that were collecting the amount of water that we use, micro sprinkler in each spot, and like I said, the tunnel to control the rain. So let's go a little bit further with the tensiometer. So tensiometer, this is one example of tensiometer with a probe, and you have a ceramic here, and the water will go in and out of that tensiometer, and it will measure the tension in the soil. So if you have a lot of tension, your soil is dry, and the plant is having a lot more trouble to get that water from the soil. So it really gives you an idea if it's easy or not for the plant to get the water. So if the tension is way higher, then the plant will have more trouble. It will start not being able to get the water and it will stop growing. So you can put the probe in the pot like that, and it's connected to the hub with a solar panel, and it will send the signal by cell, like a cell phone. So you're going to receive the signal either on your cell phone, on your computer, and it's all automated, so it can be controlled by the hub in itself to control the valve. So there's different option. You can just have an alarm and say, okay, I need to go to that place because it needs to have some water, or you can put an automatic valve there. So with that, what we did is we had our reference species, like in that case, it was a spirit, and we had the tensiometer in it. This is the cord of the tensiometer. And once it was reaching the threshold of that species that we already established in the past, when it reached -6, it was starting the irrigation. So we had a comment from the tensiometer, and it will open the irrigation for the entire line. So all the species that were clustered with that reference species were watered at the same time, and were receiving the water that the spirit would receive. So if a plant was well clustered, it would be ideal growth. But if a plant was growing way faster than that reference species, then you would start having trouble seeing sign that the plant didn't have enough water, was growing poorly, or had way too much water, and it was just losing water for no reason. So that was the goal there. So you had all the plants that were associated with the cluster. We had 8 reference species and 4 replicates, so in 2 different tunnels. So here are the reference species. We had 4 shrubs and 4 perennials, and we did try to choose shrubs and perennial that had different needs in terms of water. So high needs or really low needs, or in different kind of pattern of growth in the season, as you will see in a few seconds. So on that, here are the shrubs that we did cluster with those reference species. And I won't go into much details about each of those because we're going to put all of that in the report that you can go and see on the website. But I'm going to show some of those plants. I'm going to show the results just to give you an idea of the kind of result we can observe. And so we had those 13 shrubs and 12 perennials. And we had different kinds of perennials, some that grow really quickly, other that were really more slow to grow, different kind of need also in terms of water. So let's start with the reference species in itself. So what did we observe during the season? So here you have the list of the 8 different reference species. And this is, if we look at the end of the season, you will see that you will have some kind of different kind of water needs. So you have those 3 here that had similar amount of water that they needed during the season. And then you have here one that is a little bit more in the middle, and you have those 3 here that are a little bit lower. And then you have the Emerocalis here. So that one was quite of a surprise because we were expecting all those 7 here. We were expecting that kind of pattern. We did choose them because of that. Emerocalis is normally, so daily is one that grow really quickly, and normally is supposed to be around here. So it needs a little bit more water than what they needed this year. And what did happen is that the plug that we received for that species, and it was the first time we did have that, I think had some kind of disease, probably viruses, although it wasn't that clear. But they didn't really grow this year. They were stunted in their growth, and normally they grow really quickly in the beginning of the season. So the plug quality wasn't there. And so it kind of gave us results that were unexpected. Normally it would be more around that. But beside that species, we had a good range of water needs. One of the things that I wanted to show you was the group of 3 here that we have that need about the same amount of water during the season. But if you look during the season, it's not the same thing at all. So if we go after 5 weeks of growth, you have the Rudbeckia, that needs around 60 to 70 liter during that time. But if we look at the astilbe, another perennial, it's about half of that amount. So we can see that there's a big difference during the season in terms of water need, even if at the end it's the same amount of water that they need. So we were curious to see if we could improve the clustering based on those different kind of patterns during the season. And so we did look at our results, and I'm going to show you a few examples. So here we have Merica Gale, and it's clustered with 3 here on the picture, 3 different species. We have Tuya, and we have Hydrangea and Salix. And you can see that there's a big difference in terms of growth. So here for the Tuya, it wasn't good enough for that species. It needs a lot more water. And you can see here that Salix provide that kind of water. What is interesting is if we look there, so we know that it needs a lot of water, that species, but if we look there, they had about the same amount of water used during the season. But Salix was superior to the 2 other. And if we go back here and look, we can see that the blue here, the Salix is kind of in the middle. So it needs a little bit more water than astilbe, but a little bit less than Rudbeckia, and actually needs more water when we go at the end of the season. So it's just to show that it's important to choose a plant that have similar growth patterns. So Merica and Salix had a similar growth pattern a little bit later in the season, but had constant need of water during the season. So that's why we recommend to put them together. There's another thing that we need to look at. This is here with Salvia, is we can see if we look at the final biomass at the end of the season, those species are about the same. So Rudbeckia and Salix are about the same. But if we look in the middle of the season, that wasn't the case at all. So we have here Rudbeckia and Salix. So Rudbeckia was provide a lot more water in the beginning of the season. So it did grow really, really quicker. So you had a better growth, a better looking plants, flower more quickly, so better quality of plants that you can sell right away after a few weeks. So that's another thing to consider. It's not only the end of the season, but also in middle of the season. So I did show you until now 2 species that needed a lot of water. Now I'm going to show you one that is more standard to what we do observe, which is that you can have bad growth if it doesn't have enough water, and then you're going to have some kind of plateau where it's going to be the same size of the plant, whatever amount of water you're going to give, and at some point you can have some kind of have too much water, and then it's going to be a problem. But in that plateau, you can use whatever amount of water, and but you're going to use a lot less water if you choose that cluster here. So if you combine with Tuya, you're going to use 50 liters of water. Instead, with Salix, you're going to have 200. So it's 4 times less water if you combine with that species here. So if we go with those with 3 species that had similar water needs, so if we go back here, if we look here, Tuya, Spire, and Asta, they have a similar amount of water that they're going to need, but you see that the growth is not the same at all. So why do we have such a difference? So if we go during the season, you can see here that Asta is having needing a lot less water in the beginning of the season, and then it's going to increase at the end. And it's clearly not enough for that species of Simicifiga. So what it does, it creates a lot of stress, and the plants start to flower. But its size is way, way, way smaller than Tuya. So it's another example to show that it's important to look at the growth during the season and try to combine reference species that have similar growth. So you can think, well, that's a good thing. I'm going to have some kind of a flower more quickly to sell the plant. But what we see is often also damages on the leaf, which is not a good thing for the quality of the plant. So here it's another example where we look for perennials again, and we just saw an example where we had less water, we had more flower, which can happen with some species, but in other, it's the other way around. So here, the more water we were giving to that Polymonium, it was giving better quality of flower early in the season and a good biomass at the end of the season. So the final example that I want to give you is one that we saw a couple of times with smaller plants is if you give them more water, like we see here is you won't see an increase in growth. So basically what it means is whatever species you're going to use there, you're going to have similar growth, and actually you're going to have even a better growth if you have less water. So in that case, you're better to go with those low amount of water, apply in cluster with Osta, for example, or Spire, will give you better quality plant. So it's important not to combine them with plant that ask a lot of water like Salix or Astil, because you're going to lose too much water by leaching. So the takeaways for that part are that optimal clustering lead to significant reduction in water use, and that speed of growth is an important factor to consider when choosing your reference species. Because water use varies during the season between species, like I show you. And another thing that you can add is variation can arise from the plug quality, either because of vigor or diseases. So it's a really important thing to consider if you start doing clustering. Look at the quality of your plant first. So what we're going to do next is 25 new species to come next year and give you more result with that. So the next part that I'm going to show you is the automation strategy. So we went to a nursery, a partner in the project that have a commercial nursery. And we had an experimental setup with wireless tensiometer, automatic valve, water meter with a weather station, 2 species in cluster, bark-based soil mix, the N7 from Fafa, and sprinklers. So we had micro sprinkler at the nursery at Laval University. This time we had regular sprinkler, big sprinkler. So we did look at either fully automated irrigation with wireless tensiometer, and we did compare it with evapotranspiration prediction-based irrigation based on weather station. And I'm going to come back with more details with that. And finally, we looked, we did replicate the grower irrigation strategy. So he did buy new sprinkler that were more efficient, and we wanted to see what kind of result would we have by comparing the amount of water he was using. So if we go back with the evapotranspiration calculation, we use that equation here. I won't go into too much details, but it take into consideration temperature, wind, solar radiation, and humidity. And once you have that equation, it's going to give you a reference for evapotranspiration, and then you adjust it with a coefficient for that species. And then you do a daily irrigation based on water loss prediction. So I'm going to give you a quick example just to show you. So let's say that your weather station here tell you that you lost 4 millimeter of water for the reference of evapotranspiration, and your coefficient is 2 for that specific period of the year for that species. So you say you just multiply 4 by 2, and then you say, oh, I need to put 8 millimeter for that specific species at that date. And then you do the amount, the minute of irrigation based on what your sprinkler will deliver to the plant. So did it look during the season? This is the crop coefficient. We did use 2 different coefficients. One that is a little bit higher, one that is a bit lower, because we were trying to reduce water use by as much as possible. And as you can see, it's kind of a linear, it increased linearly, except when you have a lot of rain during a period of time, because then you cannot really measure the growth of the plant during that time. But you can see that it's fairly linear, and then we're going to try next year to use that equation to make it even more easy than try to monitor it on a daily basis. So if we look at the result, we have, in terms of growth, we were using 2 different species, and those are the 2 different species. And we were quite happy to have no differences between our 3 different treatment here. So tensiometer and evapotranspiration. And if we compare it with the grower that we were replicating, so like I said, it was using a really high efficient new sprinkler, but I think it was maybe a little bit too much in terms of water reduction. So we had a little bit of less growth in terms of that species. So if we look at water use, one of the things that I showed you last year was that when we use tensiometer, we had a better use of water per plant. So it was really, really efficient here, that one here. And when we compare it to evapotranspiration, it was not as efficient last year. And we did try to improve it this year. So the good news is we were able to improve it. So we were about the same level as tensiometer, even a little bit better. So it's a good news in terms of efficiency. And in terms of grower condition, like I said, it was maybe a little bit too dry. So that's why we had some kind of growth reduction in terms of the plant, but it was also really efficient in terms of water use. So the takeaway for that is that controlling the irrigation by tensiometer is really highly efficient, and that's what we had also this year. It's way more easy because then you don't need to do all the look at the calculus and change the coefficient during the season. So it's really easy to use, reliable, and really efficient in nursery. But evapotranspiration can be as efficient for water management, and that was a good news for us. But you need to adjust the coefficient rigorously during the season, and the good news is necessitate less equipment, so it's more affordable for more nurseries. And what's to come with that is to compare automation strategy with tensiometer again next year and refine evapotranspiration prediction. And on that, because I'm a little bit late on time, I just want to thank all our partners. Really appreciate all your help, and it's without you, we could not do the project. So we have FAFA, Scott, Ortho, Multiplan, COHA, all partners of the project. And I'm ready to take questions.